Hello, Mr. Martino here for your favorite teacher. We're going to continue our solutions to the Unit 3 Further Algebra for Pure Math AS1. So question 3 starts, find the first four terms in ascending powers of x of the binomial expansion of 2 plus px all to the power 9. So firstly, we set up our expression for expansion. So our expression, because it's going to be to the power 9, is going to be 9c0 times 2 to the power 9 times px to the power 0 plus 9c1 2 to the power 8 times px plus 9c2 2 to the power 7 px squared, and finally plus 9c3 2 to the power 6 times px cubed. These are just numbers that we can now put into our calculator, and if we do that, we get it's equal to 512 plus 2304 x p, or I should say px, plus 4608 p squared x squared plus 5376 p cubed x cubed. So that's the first part of the question. Second part of the question states that given that the coefficient of x cubed in the expansion is minus 84, first of all, find the value of p. So this was A, and now we go B. So we told that the x cubed coefficient, which is 5376 p cubed, that is equal to minus 84. So now all we need to do is solve for p. So we get p cubed is equal to minus 84 divided by 5376, which simplifies to 1 over 64, and therefore p is this cube root of minus 1 over 64, which is minus a quarter. So that's the first part of the B. The second part says, find the numerical values for the coefficients of x and x squared terms. So the x and x squared terms from part A become 2304p, which if we use p is equal to a quarter is minus 576. And the second part is 4608 p squared. And again, if we put p is equal to a quarter, that comes out to 288. So that's our three sets of questions answered there in that particular one. Number 4 says fully expand p plus q to the power 5. So we have p plus q to the power 5. And our expansion again becomes p to the power 5 plus 5p to the power 4 times q plus 10p cubed q squared plus 10p squared q cubed plus 5p q to the power 4, and then finally plus q to the power 5. Notice the symmetry always in our expansions. The second part of the question says, a fair four-sided die numbered 1 to 4 is rolled 5 times. So let P represent the probability that the number 4 is rolled on a given roll. So as soon as we see that, we can say P would be equal to 1 over 4. And let Q represent the probability that the number 4 is not rolled. And therefore, Q is 3 over 4. Using the first 3 terms of the binomial expansion from part A, or otherwise, find the probability that the number 4 is rolled at least 3 times. So for the number 4 to be rolled 3 times, it needs to be rolled 3 times, 4 times, or 5 times. And that means that we use the first 3 terms in our expansion. So we have, since P is equal to 1/4 and Q is equal to 3/4, the probability X is greater than or equal to 3 is P to the power 5 plus 5 times P to the power 4 times Q plus 10 times P to the power 3 Q to the power 2. And that, if we put it into our calculator, all works out to be 53 divided by 512. It's important to note that we are modeling our probability based on the binomial expansion, and we can always do that in this type of scenario. I hope this has been helpful. This is Mr. Martino for your favorite teacher.